All right, guys, attention, please. So you should have your half pipe part open by now. If you remember, the most recent thing we did was a mirror. You did not have, however, these two guys. So these are what we're going to add in here. This is not uncommon at all when you make a part for a particular purpose. They want to save on material or they want to save on weight, perhaps for shipping purposes or whatever. So we're going to make these indents here, these cuts, to sort of lighten the part, make it less heavy, use less material. Notice they do not go through all those. So when we do the cut on these, we're going to have to do an end condition of offset from surface. Perhaps you remember that from when we did the cooler part. So we're going to do something like that. Another thing about it is I only drew one of them and then added it to the mirror. So here's what I'm going to do. I'm just going to delete mine right now because I just wanted you to have a look at what we were headed toward. Okay, so this part is essentially the same as yours. So what you want to do now, yes, ma'am. Okay, very quickly then, Abby, click on Tools. Scroll down using the arrow at the bottom until you can see Customize. Little arrow at the bottom of the Tools menu. You click Customize. Move this window around until you can kind of see the place where you need to put it, so that you can see this, but the window is just below it like this. Okay, click the Commands toolbar, Commands tab. Choose Standard Views at the bottom of the Categories thing. Just click and drag that up to where it belongs there. Click and drag this to there, okay. And then you can close that. Since you're already in your old part, we do not want to save this as your template. So we'll have to go back later and save a template. If you save this as a template file, it would save all of this. Every time you made a new part, this would show up and you have to delete it all. So just for today, we're just going to stop there. I'll go back over at the end of class today. Yes, Walker?
I wasn't here Monday, so do you have any time, like maybe tomorrow?
Where are you right now on your part?
So I have the last thing I remember we were about to do, but then.
Are you here? No threaded holes, or are you?
Yeah, I don't have any holes.
But you're
But I have
past that.
Yeah, I have the extruded cut opposed.
So you've got that. It looks just like this right now?
Yes.
Okay, so yeah, I'll have to show you how to add in some tapped holes on the side and on the top. That's those two guys there. What computer do you use?
9.
What computer do you have, Abby?
I have 3.
Who has computer 9? Way to come in late and then that disrupt everything. Maybe if you'd been here on time, this wouldn't happen. It might not be in the right shelf. People put them in the wrong place all the time.
Is it the one that?
No, Tommy took number 21, which was the one Abby was using. All right, so anyway, moving on. So yeah, you're gonna have to learn how to do those tapped holes. And then we did something called mirror. Mirror is pretty cool because what it allowed us to do was to take those features and just mirror them over to the other side. Okay. Now here's what I want. Did you find it?
No.
All right. So here's what we're going to do now is we want to add in a new feature here. We got to do some sketches and some features to make it. And we're going to mirror them as well. There's no reason, Walker, you can't do this and omit the threaded holes for now. And I'll show you how to add mirror. But these guys already have a mirror in there. What's cool about this next thing we're going to add is we really want it to be symmetrical. So ideally, we'd use that one mirror feature to mirror all of the things we want. So here's what we're going to do now. We're going to roll back this part so that the mirror feature is suppressed. We're going to add a new feature in between the tapped hole and the mirror. And when we roll forward, then we'll just add that feature to the mirror. Does that make sense? So move your mouse over in the design tree over here on your left until your cursor looks like a little hand on that blue line, and click and drag up one step like that so that the mirror gets suppressed. and that our activity, the place we're working, is between the bottom of the two tapped holes and the mirror. In your case, Walker, you'll just start from where I'm going to start here momentarily, because you don't have the mirror or the tapped holes. Sebastian, where are you right now?
I'm logging in.
Okay. As soon as you can, open the part.
Before I had everything already did the mirror.
All right, so open up the part when you can and roll back the mirror like I just did over here.
It's on a different computer, I just have to.
The only thing is you won't have the normal tube.
Oh, but that's an easy.
Yeah, it should be pretty straightforward. So let's just go ahead right now and let's right click on this front face surface that we want to work on and start a sketch. Okay. I'm going to go normal to that. In fact, actually, let me show you something, Sebastian, while you're here. If you right click and first choose the normal to,
Okay.
so you just have to think ahead a little bit, and then right click and start the sketch. You don't actually have to have this thing here. Yes?
Never mind.
You got it?
Yeah.
Okay. Now, we're going to sketch a rectangle in here. So turn on the rectangle tool. Choose the corner rectangle, although honestly, for this part, it doesn't matter whether you do the corner rectangle or the center rectangle, but I'm going to use the corner rectangle tool, and I'm going to just click. Oops, let me turn it on. Let me click kind of up here in this sort of left area near the side and drag down like that. So there's my rectangle. I'll give you a moment to look at it so that you can get the same thing. So does everybody have a rectangle sketched on the left side of one of the faces of their part? You can close that dialog box now. Now, one of the things we want is we don't want this hole that we're making, this indentation, to run into any of the screw holes that we have. Yes, sir?
It says you must accept the license agreement.
Just say yeah.
Yeah.
Yeah, it's fine.
It would like add different, like another subscription.
No, it's no problem. Thank you for asking. So we would need to be able to see where those screw holes are. Now you can kind of see them in mine. Yours might not even be showing those, but there's a way to be sure you're seeing hidden lines such as those. And that's to go to the top up here under the display style option of the, so it's the second cube, the cube next to the eyeball. Click the down arrow next to that and choose the second one from the bottom, which is hidden lines visible. It sort of makes your part transparent, like it was made out of plastic or glass or something. And now you can actually see precisely where those holes from the threaded holes go in this part, and it'll allow you to, while you're crafting a part, prevent something from running into something else. We're going to define the location of this completely by dimensions. So let's start the smart dimension. Click on this side of the part and the nearest side of the rectangle you're making. Pull over to the, way a little bit so you've got some room so you can see the number clearly. Click a third time. And we're going to put in 0.125, which is also the same as 1/8 of an inch. I'm going to mess that up here. Let me see, backspace. 0.125, 1/8 of an inch. And I'll click check. And so it actually moves it so I can see, yeah, that's a reasonable distance from the side. So this is the first time I'm designing something sort of on the fly. I don't have the numbers ahead of time. I'm making them up as I go along. So what's cool about the smart dimension is when you put one in, it gives you the number that it currently is sitting at. So currently I feel like that's a little too close to the end of this hole here. Like those two are kind of close together. So I'm going to smart dimension from the top of the part down to the top of this rectangle. I'm going to pull over into this space so I can see that number clearly. I'm going to click, and I see it's at 0.5156 something right now. I think that's too close. So I'm going to type in 0.55, and let's see if that maybe looks more to my satisfaction. So I'm going to click check. And yeah, I think that's a pretty good gap there. So I'm going to leave that measurement alone. 0.125 looked good over here on the left. So the right side of this, I'm going to click on the opening and on the edge of the part, come over here where I can see my numbers clearly. And I'm going to type in 0.125 again for that. So that's 1/8 of an inch from that edge. And then lastly, I want to dimension from here to the bottom of the part, like this. I'm going to make a guess of 0.4 and click check and have a look. 0.4 looks good. I'm curious what 0.35 would look like. So I'm going to double click that number and try 0.35 instead. Let's see what that looks like. Ooh, that's too close. 0.4 was better. So I'll double click and go back to 0.4. So you see how you can, while you're designing a part, you can kind of in the sketch play with your numbers and relations and delete things that aren't right and change numbers that you put in there, so that if you're designing a part really where you're not sure about certain relations or dimensions, you can try stuff out, and if you don't like it, you can always change it. So I'm satisfied with 0.4 there is a pretty good number for that. So this is now fully defined. I can turn off my smart dimension here. It's fully defined. I'm going to change my view of this part, my display style up at the top by clicking the down arrow next to that cube, back to the standard one, the one at the top that I like. And I'm going to exit the sketch. Now all I have right now is just a sketch on that face. I haven't actually cut anything yet. I'm going to pause and give you guys a chance to catch up. Yes. Sure, yeah, I'll go back into that. I'll just edit the sketch and it'll show me those dimensions. So it's an 1/8 of an inch from the left, 0.55 from the top, an 1/8 of an inch from the right, well, the right side of the half pipe section, and 0.4 from the bottom. No, I just took it from this top edge to this top edge. I just click that side and then click that side and then pull over in the middle and click the third time. Liam, you good? Albert, you got it? Mark, you good? Nicholas Stone, you good? And Lampert? Okay. Jacob, you good? Yeah, you don't have to use shift. Most of the time, you do not need shift in Smart Dimension. 90% of the time, you don't use shift in Smart Dimension. In fact, I would say, I think with confidence, that the only time we're going to use shift with Smart Dimension is if we have to make a circle be dimensioned by its radius, which we did one time. You do not need shift for Smart Dimension. Now, if you want to add a relation to two things, then you need it. So when you're adding dimensions, you'll often use shift to be able to select multiple items. But when you're adding, that's relations. When you're adding dimensions, you do not typically need to hold shift. Yes. Again, the bottom line to there. Yeah, I just pull it over to the side. You could do it from the point to the bottom, but since the two lines are forced to be parallel, it's better to dimension from the line to the line. If you have an option of dimensioning from line to line rather than from point to line or point to point, it'll always be superior. And I'll show you why later. Sam, you good? Rohit, you with me? Walker, you there? Although you don't have the threaded holes. But as long as you use these dimensions, you don't need the threaded holes. But you saw how I made it transparent so I could see where they were. That's important to be able to make it transparent sometimes to draw a sketch, and then you make it back untransparent as you continue working it. Mark, you got a question, or was that Sebastian, you're caught up now? Yeah. Everybody's good. Awesome. So we can exit this sketch, not with the red X, of course, because you don't want to lose our work, but with the blue thing. And now we want to select that sketch over in our design tree and choose extruded cut. Now, important you pay attention right now, not be talking, because we're going to do something, we're going to do the offset from surface thing. Before I do anything else, I want to rotate this part so I can see the surface I want to offset from. So over here in the design space, I'm going to click and hold my scroll button and pull my mouse to the side so I can see the back side of this part. I do that sort of anticipation of changing my end condition to offset from surface, because sometimes if you change the end condition first and then you try to move the part, weird things happen. So I usually orient the part before I change my end condition. For Tommy at home, if he does not have a mouse and he's trying to use the pad and the arrows, it's especially important under those conditions to rotate it first before you change your end condition. Because if you start using the arrows to, and you can do that, I don't know if you noticed, but if you use the arrows on your desktop, you can rotate it that way as well. But if you choose this end condition, so go over to the left now, guys, change your end condition to offset from surface. Don't do this, but I want to show you what happens if you're trying not to use a mouse and you try to use your arrow key now to rotate the part. Instead, it rotates through the different end conditions. See how my design tree is changing instead of rotating? And you don't want that. So that's why I got into the habit of always rotating it before I changed my end condition, because I was using the keyboard and the arrows but if you're using a mouse, it's not really as big a deal. Anyway, the surface we want to offset from is this back surface. So you click it while that box is blue, and then you change your dimension to 0.05. We're going to go down to 5/100ths of an inch, just a little kind of piece of tin foil almost between the end of this hole and that face that we have selected. We're offset from that face by 0.05, 5/100ths of an inch. Click check, and click check a second time. Scroll, click, and drag to look at the hole you've made. Now this hole looks different than the one I started class with because this hole has square corners. That edge right there, that one little line that I'm on. Abby, you're frowning again?
No, I see it. I do not have a hole. I don't have a hole either.
0.05 from the back surface. If you do accept on your cutting, now if you did boss extrude instead of cut extrude, that'll make sure you don't have a hole because it didn't cut, it added, right? You don't want to do that. Is there any chance you did boss extrude, those of you that don't have an indentation? It does say cut extrude? Well, edit the feature. Check that you're offset from surface. Make sure you chose the opposite surface from the side that you drew the sketch on.
Yeah, I don't know what's going on.
All right, I'm going to come and help you. So I'll be right with you. You got it. But there's certain people. You're a certain person. How certain are you? Well, you just haven't clicked the check yet.
No. I clicked the check at the first.
Click check. Click it again. Oh, you don't have one. All right. Click on that sketch briefly. You put your sketch on the mid plane. That's why. So there actually is a hole in there. It's a cavity inside of your part. Okay. No, let me show you how to fix this because this is kind of cool. Let me go up front. I'm going to show you all of you how to fix this. Okay. Give me a moment to mess it up in precisely the way that Rohit did, and then I'll show you how to fix it. Okay. This will happen to you. Sometimes you'll make your sketch on the wrong plane, and you'll have to fix that. He put his sketch on the front plane, which, as you might recall, is actually inside of the part. The front plane, if you look at that, is right there. It passes right through the center of the part. Okay, and so after he did his cut extrude, he didn't see anything. But let me show you something interesting. If we change it to the transparent, there actually is a cavity in there, starting in the front plane and offsetting from the surface by 0.05. So the deal is it cut extruded from that plane where the sketch was drawn, offset from the back surface, but that's not really what we wanted. Now, there are a couple of ways to approach this. The way I would prefer, Rohit, please pay attention. The way I'd prefer to approach this is actually move my sketch from the front plane to the front of the object. So that's how I'm going to do it. There is another way to do it. So let me show you both ways. First, I'm going to show you what I think is the less superior way. If you edit this feature, there is a direction to option. And if you direction to and just make it through all, it cuts the other way through all. So it keeps your sketch on that plane, cuts in one direction, offset from surface, and the other direction through all. That's kind of hacky because you didn't really put the sketch where you wanted it. You put it in the middle and then cut in both directions. So it would be bad design intent in my opinion. So we're not going to do the two direction thing. We're going to leave it, just cut the one direction. What we're going to do instead is we're going to move where the sketch is. So pay attention everyone to this because you will at some point draw a sketch on the wrong plane and go, crap, I wish I'd drawn that sketch somewhere else. To move a sketch after you've made it, even after you've applied a feature to it, you can right-click on the sketch, and the second icon, Edit Sketch Plane, comes up. When you choose that, it shows you where you actually put the sketch. It was on the front plane, but it also gives you the option to click something to replace it. So now I'm going to click the front surface of this. So now it's face 1 is what it's now on. Now if I click check, the cut goes all the way through. I just moved that sketch from the front plane to the front of the body. Did you do that, Rohit? Yeah, and it fixed it, right? Awesome. All right, so now moving on, the next thing we need to do, by the way, does everybody have this now? We're all in the same place? Awesome. So what we need to do now is, if you noticed when I first brought this up at the beginning of class, these were not sharp rectangular corners here. Instead, this was sort of rounded off. Now, that's called fillet. Some people call it fillet. The fillet tool is interesting because it does two different things depending on the kind of edge you click. If you click an edge like this, where it's solid bodies coming outside to an outside corner, much like this corner is here for Tommy, he can see. If you were to do a fillet on that edge, it would actually remove material. It would round that corner over, much like the corner of this television is rounded over here, or the corner of this desk is rounded over in the front here. Okay, so that's a fillet on an outside corner. The opposite of outside corners are ones like this. This is what I call an inside corner. The one that's highlighted red, orange on your screen. That's the same as if you look at this cardboard box, okay? This would be an outside corner because you would round off, you'd remove material, like sand that down, think of it that way. This would be an inside corner. There, it adds material to fill in the gap. In fact, I don't know for sure, but it seems like fillet. I got to fill it here, fill it the corner inside there. Anyway, the reason we did this was because generally when you're manufacturing a part of this type, you use a tool that is cylindrical with cutting blades around the outside of it to make this opening in the flat part. It's called an end mill. And so when you plunge down into the surface like this and move around, when you get to a corner, it's actually going to leave a round corner rather than a sharp corner. So there's one reason. Another reason is if you made a mold for it and you were casting it out of plastic, for instance, it's also a good idea to have rounded curves, filleted curves, rather than sharp ones, because sharp ones, things will tend to stick. The plastic tends to stick to the mold when you have really sharp corners. But if you have rounded corners, it releases better. So we want rounded corners here. We want to do fillet. Now, fillet, as you know, applies after, I'm sorry, you don't use a sketch to use the fillet tool. You basically launch the fillet tool with nothing selected. There are actually 1, 2, 3, 4 kinds of fillet. We're only going to do the first one here, which is called a constant size fillet. And the first thing we're going to do actually is tell it the radius of this fillet we're going to do. And we're going to make that radius 0.125, an eighth of an inch. That means we'll be using a 1/4 inch tool to make the opening. 1/4 inch diameter tool will give you an eighth of an inch fillet as you go around. So we're going to do that, and then we're going to click up here in this blue box. And this is when this is selected, if we click on an edge, like that little line right there, it will, oh wait, one other thing, I'm sorry, I almost forgot. Be sure you choose full preview. Full preview. Underneath the blue box, be sure you choose full preview. It defaults to no preview or partial preview, I forget which I don't understand. Maybe so some computers, they can't handle it. I don't know, but I like full preview because you can see what you're doing. So if you were to now click into this inside edge only, that one little line there, it'll give you a preview like that. I want to show you though, sometimes you mess up. People make mistakes. If you actually click on this face here, it tries to apply a fillet to all the corners and it can't do it. So it just erases everything. So we don't want that. If you accidentally click on the wrong thing, if you move your cursor over to this items to fillet dialog and you right click on one of those entries, you can click delete and it takes it back out. Likewise, if you actually clicked on this top face, it would try to apply a fillet to every edge of that face, like that. And that's not what we want. So I'm going to go over here to the face 2, and right-click on this and delete that. It does allow you to do multiple fillets in the same feature. So you don't just do one and close it and start fill it again. All we need to do is rotate the part so we can see the next inside corner. So I'm going to move my cursor over here in the design space, mash down the scroll button and pull my mouse toward me a little bit so I can see this edge and choose it. And then I'm going to scroll, click, and drag and choose that edge, and scroll, click, and drag and choose that edge. And now it shows me preview of all four corners of this thing are filleted like that. Again, if you get something that doesn't look like that, no big deal. Come over and delete things on the side here until it's back to showing you what you want. Does everybody have that filleted? What you need, Mark?
What would happen if we click fillet expert?
I have no idea. I've never used it. It's a worthwhile question. There's a lot of things. I know it seems like I've taught you a lot, but really, even when I'm done, we'll have only scratched the surface of all the different things it could do. I never used Fillet Expert. I never used Dim Expert either. I know some of you guys have been clicking Dim Expert, and it causes problems. It's not the way to go. It's a tool. SolidWorks put it in there. I'm sure there are people who use it all the time, but the tool I understand how to use doesn't have the expert part in it. At any rate, once you get all four of those and they're all 0.125, click the green check in the fillet box, and there we go. We've got one of the two holes we want. Liam, you good? Albert? Sebastian? Mark, you got it?
Yeah.
Two Nicks, both good. Jacob, good. Walker, you working?
Let's see. It's kind of close.
Lampert, see if you can help him.
No, but I did that. I clicked that by mistake. They got the.
There you go, Rohit. You tell him. Abby, you good? Max, where are you, buddy? Max, you with me? Mila, you good? Lenny, you're good at this, right? You're doing great. I'm very impressed. You've asked very few questions.
Thomas, you hear that?
This is Tommy wants to make sure you hear that. Lenny, I remember when we were doing Excel, you asked a lot of questions but this time you're like right with it. So this is more appealing to you than Excel in some ways? It's more visual. This is good for visual learners. All right, guys. So everybody has that. Yes, no, maybe? All right, I'm going to move on to something else. So just grab another one. Leave me that one if it's got problems. I'll probably toss in the trash.
I don't know why. It just wouldn't.
Okay, so here's what we're going to do. We're going to go back over to our design tree. Focus, please. We're going to roll forward so the mirror comes back up. Notice it only mirrored the holes. It did not mirror the cut extrude we did here or the fillet that we did. However, we can add those to it. All we have to do is everybody should be paying attention now because I'm going to give you new instructions. Right-click on the mirror feature in your design tree after you've rolled forward and click Edit Feature. And then you should get the half pipe expansion over here. If you don't, just click this down arrow here to bring it up like that. Okay. And then just add the cut extrude and the fillet. Just click on both of those items over here. And then when you click check again, now those are mirrored as well. Oh, I'm sorry. He doesn't have the mirror tool, so I'm going to show him real quick how to add it. I'm just going to delete it here. Say yes. So if you didn't have a mirror activated yet, so you're here, except for you don't have the holes. Is that right, Walker?
Yes.
Okay. Go up to the linear pattern option and click the down arrow. And one option there is mirror. It's a type of feature. It's under your features tab at the top. Features tab, under linear pattern, there's mirror. The first thing you have to do, quiet please. It is impossible for me to communicate this way. There's literally no reason whatsoever that you should start talking anytime I'm not directly addressing you. You have wasted literally hours since we started this by doing exactly that. Please, guys, this could go so much smoother if you just sat quietly while I was trying to work with individuals. Everybody gets their turn being worked on individually. Show some respect. If you don't have the entire listing of things here. Click this down arrow next to the half pipe thing right here at the top. And it basically what it is while a dialog box is being displayed over here, it moves your design tree over into the design space in a compressed way like this. And you can expand it by doing that. Now, the first thing you have to do when you do a mirror is you have to tell it what plane to mirror things around. In this case, it looks like the right plane would be the ideal one to mirror it around because that goes right through our object because of the way we did our very first sketch. So click right plane, and that fills in this first box at the top left of your dialog box. It says that's the plane we're going to mirror around. Then under features to mirror, you want to mirror, well, I'm going to want to mirror the two tapped hole options, the cut extrude, and the fillet. If I mirror all of those, and then I click check, those all mirror over. See that? Now, Walker, what you'll want to do later is roll back above that mirror and add in the tapped holes.
Yep.
And then roll below the mirror, edit that feature, and add the two tapped holes as an option.
I'm having a little trouble. There was no other mouse, so I don't have a...
Yeah, you should really use a mouse. I know how to do it without a mouse, so I'm going to give you this one. But what I click on up here and the way I do things might look slightly different than what all of you guys are going to see. It's essentially the same thing, but it's a little bit. I'm going to try this mouse. What was the mouse doing that was weird?
It was like the red was on. Yeah, the red was on. It just wasn't.
Yeah, all right, it's working for me right now. I'll keep using it until it doesn't. Okay. All right, so we basically are finished with this part. What I would like to do now is one of the frustrating things about this has been there hasn't been much flow. We've always had to stop between things, and so it makes it hard to recall what happens. So I'm going to ask you now your indulgence for, I think that takes about 6 minutes. I'm going to draw this entire part, starting from new part, okay, and just watch what happens. And this will show you, and try to anticipate what I'm going to do, but just sort of watch it. So I'm going to go to the front plane and start a sketch. I'm going to do a center rectangle whose center is on the origin. I'm going to smart dimension the top part of this to be 3 inches and the right side of this to be 1.5 inches. That fully defines that part, so I turn off this dimension tool and exit the sketch. With the sketch selected, I'm going to extrude boss base. I'm going to change my end condition to mid plane because I want to go in both directions, and my dimension will be 0.25. So it creates a part that's 0.25 thick, but equally in both directions, leaving my origin in the dead center of the body. Next, I'm going to right click on the front plane and start a sketch. I'll go normal to it and start the circle tool. I make a quick circle over here to the side. I'm going to click again so I'm not selecting anything, and then just click the center, hold down shift and click the origin and make those vertical to each other. So that'll hold it in the middle. I'm going to smart dimension this. I'm going to want to do the radius instead of the diameter. So I'm going to have to use the shift button. One of the only times we use shift while doing smart dimension. I'm going to hold shift down. I'm going to click the center and then the edge of this circle and come over, and that allows me to dimension it by radius. 3/8 of an inch is the radius we want, so I'm going to click check. And so now that's dimensioned in size. Notice, however, I can still move it up and down. I need to dimension it vertically. To do that, the designer of this said that they wanted the dimension to be from the bottom of this circle to the bottom of the body here. The default, if you just tried smart dimensioning it, would be from the center of the circle. So we're going to have to add a point. So I'm going to turn on the point tool here. I'm going to move until I get both of these little yellow preview boxes for coincident and vertical. And when I click, it creates that point with those two relations already in place. That's important because what that means is let me turn off my point tool. What that means is I can't move this point around on that circle. It's going to stay stuck to the circle at the bottom. Now I merely need to turn on smart dimension from that point down to the underside of the part. So I click on both of those, 0.25 inches, click check and exit. Now I've got it fully defined. I exit the sketch. With the sketch selected, I do extruded cut. I choose my end condition to be through all, and I accept that feature. So now I have a hole that goes all the way through. Now I'm going to make another sketch on that surface. It's going to be a corner rectangle where, let me go normal to it, where one corner is up here on this surface and one corner somewhere on the circle. I'd want this line here to be tangent to the circle. So I click that line, hold down shift, and I click the edge of the circle. Both are selected now, the edge and the line, and I make them tangent to each other. I click check in my dialog box to close it. I choose this line by left clicking, hold down shift, click the perimeter of the circle, and apply the tangent relation to that one. Click check in my dialog box, it's fully defined now. I exit the sketch. I apply the extruded cut feature, and I change my end condition to through all and accept those changes. So now I have the half pipe. Now I'm going to roll around here so I can look at this edge. I'm going to left click on that edge to select it before I launch the hole wizard. I'm going to go to the hole wizard. I'm going to select this kind of hole. I'm going to make sure that it's ANSI inch. I'm going to make sure it's a bottoming tapped hole. I'm going to ensure that it is number 632 in size. I'm going to make sure both of these say, this one says blind and this says blind 2 times diameter. And then I'm going to make sure that these are both gray. We want to make sure they're linked. And now I can click on this and type in 3/8. And when I hit enter, it automatically calculates the drill depth. I'm going to make sure I do not have near side countersink selected, but only thread callout. So my hole specifications are great. I'm going to go to positions. I'm going to go normal to, and notice that it automatically started the point tool for me. So I'm going to stick a hole there and a hole there, and I'm going to escape to turn off the point tool so my further clicks don't create more holes. I'm going to choose this hole center by clicking on it, left clicking. I'm going to hold down shift, the origin, and this hole, and I'm going to make them all be vertical to each other by clicking that, adding that relation to the properties. I accept that, and then I turn on smart dimension. From the top of that to the center of the first hole, I want it to be exactly 0.25. So I do that. And then from this hole down to this hole, I want that to be exactly 1 inch. So I accept that. Notice also I try to make my dimensions pretty. Pull them over to the side, I line them up. I do that. I don't make them too far. I don't like drag them way over here, but I put them, reasonably close and try to line them up nicely. That's just because as I work on it in the future, if I have to go back and change something, if the dimensions are easy to read and they're in a nice place, looks good. Anyway, exit that. Those holes are done. Click on this surface, launch this hole wizard, double check it should still have all the same specifications. I go to positions, drop one hole there, hit escape to turn off the point tool, go normal to it, click the origin, hold down shift, click the center of this, make them horizontal. Turn on smart dimension from this edge to that point right here. We want that to be 0.5. Click check there, exit that dimension, exit the hole wizard, and there's that hole. Now I'm going to right click on this front face and start a sketch. I'll go normal to it. I need a corner rectangle somewhere like this. I'm going to change my view to be transparent so I can see the holes. I'm going to smart dimension from here to here. 0.125 was the number that we ended up having that would be good. Smart dimension from here to there. I think we decided 0.55 was good there. Yeah, it looks right. Smart dimension from here to here. 0.125 worked on the other side, so it should work here. It does. And then from here down to here, over this side, 0.4, I believe, was the number. Yeah, that looks right. Exit the dimensions, change my view back to solid, exit the sketch, extruded cut, roll it around so I can see the back side, change this to offset from surface. This surface is the one I want to offset from, and the dimension is 0.05 is how far I want to offset from there. Click check. Check it. It looks right. Good. I launched the fillet tool. Make sure it's set for 0.125 over here in the dialog box. Make sure I got my full preview on and click that one edge. That looks good. I scroll click to click that edge, scroll click and drag to see that edge, scroll click and drag and left click to choose that edge. Those are all done. So I exit. Let me zoom to fit. Let me go normal to this surface. Okay, that looks great. All right, so now what I want to do is I want to mirror a bunch of stuff. So I go up here to make sure my features tab is on, go up here and choose mirror. It wants to know what plane. I have to expand this to get to the right plane. It's the plane I want to mirror around. And then the objects I want to mirror are these tapped holes here, these tapped holes here. Wait, choose it. There we go. This cut extrude. Come on, choose it. There we go. And the fillet. All of that's chosen. Click check. And I'm done. Right? You'll notice that generally speaking, what we did was we chose a surface by right-clicking on it and launched a sketch by clicking on the sketch icon. We selected a sketch tool, put it in place, and then exited that sketch tool. Then we applied dimensions and relations as necessary to get it where I want it. Once it was fully defined, I exited the sketch and immediately applied a feature. On the feature, I always was worried about the dimensions and the end conditions. When I got my dimensions, my end conditions done right, then I exited that feature, and lo and behold, we had a part, right? Yeah, and it should go quickly once you know. But see, the thing is, there's 18 of you or whatever, and you're trying to all do it together, and different people miss different things, you get behind. If you were working by yourself and you had experience, I think you could easily do this part in one class period, which is what you'll be doing when I give you a test. Not yet time for a test. But anyway, I'm going to close this one, but you should save the other one. So click your save, period 3, half pipe, and close that part. Time for a new part. This new part is going to be called axle, A-X-E-L. I'm sorry, L-E, E-L-E, L-E, not E-L. A-X-E-L is a name. A-X-L-E is a machine part. I'm going to hand out to you well, it's kind of like a blueprint. It's a engineering drawing of the part with all the all the important dimensions and some of the relations implied by what you see there. The easiest way to view this is actually not on the printed copies I'm giving you guys. I did go back and remake this with an additional image on it, which will appear on the PDF that Tommy has. So if he opens the PDF for Axel, he will have all the information he needs. Oh, Mila, I had enough for everybody, and now I don't have one for you. Let me pull it up first. So I sent this to Tommy in a PDF, but it actually was created in SolidWorks, and I'll show you the SolidWorks version here. So I made this part first in SolidWorks, and then I made this drawing, is what it's called. And the thing to look at here is this image right here on the right. If everybody will look up from your papers, this is a cylindrical object. It has a larger cylinder coming upward from this transition between the two. That larger cylinder has what's called a chamfer applied to the top. It's much like a fillet, except for instead of being rounded over, it's cut at an angle, 45 degrees, and has a dimension, 0.0625, to tell you how far to apply it down the surface. So that's a chamfer, C-H-A-M-F-E-R, as indicated there. Similarly, there is a hole drilled in the top and tapped. It's a number 1032 tapped hole to a depth of 0.5 inches, tapped to 0.5. So we know how to do tapped holes, and it's on the dead center of that. So knowing that this is going to have to be on the center of that circle, what do you think our first sketch should be, and where should we put it?
A circle.
First sketch should be a circle. Where should we put it? All right, the center should be on the origin, but what plane should we put our first sketch on? On the top plane makes sense to me. Yeah, if you think about it oriented this way, if we draw a circle for this top cylinder on that top plane and extrude straight up, and that'll also mean that our right plane will come through it sort of this direction, and our front plane will come through it sort of this direction. Our front plane will be perpendicular to us if we look at it like this, and our right plane will be perpendicular to it if we look at it like this. Does that make sense? So, and by having our origin in the very center of this, then we go to put this screw hole in here, we know the center of the screw hole just has to be on the origin as viewed from the top surface from up here on that surface of this guy. In addition to having the chamfer and the tapped hole, it also has a slot cut in it. Now this slot, if you look at it in this view here, I'm going to zoom in so you can look at this a little closer. If you look at this slot cuts from the outer surface all the way up until these two edges touch the edge of this chamfer. It even says right here, note, groove goes to depth of chamfer. So it goes to the depth of the chamfer. So what we'll probably want to do is actually make that cut by drawing a rectangle on the top of the part with its corners resting on the chamfer, and we do the chamfer before we do the groove. Does that make sense? And that way the two sort of link together. And then we'll cut that kind of going straight down from this view, which will produce a groove that comes this way. That groove will terminate with square corners. How are we going to make it end up having these sort of rounded? Yeah, we're going to do a fillet there. Yeah, so after we do the extruded cut, we'll do that. And the extruded cut will just be blind by 1.5. Does that make sense if you look at the part? And then we'll fill it at the bottom there. The lower cylinder could be created by drawing on the bottom of the top cylinder a circle whose center is centered on the origin. It'll just be a smaller diameter. It'll be 0.375 instead of 0.5 like the first one will be. Right? Does that make sense? And this time I'm spending here really is probably some of the most important time you have when you go to make a part. You think ahead, how am I going to create this part? What steps will I follow? Where will I locate things? What sequence will I do the features in? It's very worthwhile. So you'll create that and you'll extrude that 1.5 inches. But then you're going to need to put in this groove. You're going to have to cut that out of what's there. That's going to require us to use a revolved cut. Something new I haven't showed you before, I don't think. Have we done any revolved cuts? I'll show you how to do the revolved cut to get that. Revolved cut's a very cool feature. And we're going to make that cut where the top edge of it is 1 inch from this transition here. The bottom edge is 0.0625 from that transition. And after we're done doing the cut, it will leave a cylindrical bit in there, this little cylindrical part right there. It'll leave that cylindrical part of a diameter 0.3125, which is 5/16, by the way. After we've done that, then we need to make this sort of cut at the bottom. As you can see, it's sort of a flat edge has been made on there. There's the flat edge viewed straight on. And I put this drawing in here so you could see it from the underneath. So if you took this part and you sort of tipped the top away from you and the bottom toward you until you were looking dead on onto the end of this thing, you would see that this flat surface here, and there's another one behind. So it's flat both on the near side and the far side from this view, the top and the bottom as you see here. And the distance between those flats that have been cut on there is 0.3125, 5/16 of an inch. And they go 0.375 away from this end. So the way we'll probably make this is by drawing two rectangles on the end, on the underside of this small circle, cylindrical extension. Draw one and another whose points are on the edges of this circle, whose lines are horizontal, but whose lines coming in this direction are vertical to each other. They're collinear. They're in the same line. And then that means as we move it around, I'll show you when we get to it, but we're going to make that. Okay. So it looks like a really complicated piece. I can tell you my 8th period class finished it in under 1 block. More than 1 period, but under 1 block. So it's really not as hard as you might think. Mila, were you able to get from what I showed you here most of what's going on? I will give you a printed version. In fact, let me just print one right now, and I will go upstairs when we get our next break and grab that and bring it down to you. And yours will be superior to theirs because it'll have this 3D image of it. Okay, I'm going to close that. Somebody finished it? Somebody's done one? Liam? Cool. All right, so new part, okay. You with me? New part, okay. All right. New part, okay. Top plane, make a sketch. No, Tommy's not live. I'm recording for him. Sketch on the top plane, a circle. Make your center on the origin and smart dimension it to be 1/2 inch in diameter, 0.5. I'll wait and you tell me when you're ready. So in the top plane, start a sketch by right-clicking on the top plane in the design tree. Launch the circle tool. Your first click is on the origin, adding the coincident relation. Your second click is some distance away. You turn off the circle tool. You activate Smart Dimension. You click the perimeter of the circle, pull away a little bit, click a second time, type in 0.5, click the green check, and you should have this. One of the things I really like, I can look at the class. If I look at Abby, though, I know exactly what's going on in her mind. She's very expressive. Is that part of your acting training?
I don't know, it's just my face.
Yeah, but I can totally tell whether you're getting it or you're thinking or not. It's funny. Just the perimeter. You just click the perimeter and pull away. If you click the perimeter of a circle with Smart Dimension on, it automatically assumes you're giving a diameter. 0.5. I have it on the board here. Right click, top plane, start sketch, start the circle tool, click on the origin, slide over, click a second time, turn off the circle tool, launch Smart Dimension, click the perimeter, draw away a little, click a second time, type in 0.5, click the green check, and you should have this. Yeah, the thing's not very big, actually. We're just zoomed in a lot. I'm zoomed in a lot.
Where do you recommend that we have our origin?
If you look, the center of the circle is on the origin.
In the middle.
If we make our first sketch, I think if this first sketch, since we're putting it on the top plane with the center of the circle on the origin, that will make it be at that transition between the large cylinder and the small cylinder. That's where your origin will be, and it'll be in the center of the circular cylinders. Right click, I'm going to do the top one. That's why I did 0.5 is the diameter of my circle, because the top section is 0.5 in diameter. All right, we're going to move on from here. So exit the sketch. Make sure it's selected over in your design tree and choose extruded boss base. We're going to extrude it by, what does it say, 2 inches? How tall is the top half?
2 inches.
2 inches. Type in 2. Blind is all we need because there's nothing else to relate to. Click the checkbox a second time and then zoom to fit. So now we've got a 1/2 inch diameter rod sitting on the top plane, extruded 2 inches tall. Everybody good? All right, next we're going to put in the tapped hole. So we're going to put in the tapped hole by first selecting the upper surface, not one of the planes. Just select the upper surface of the body that you have there. Just left click on that upper surface. Don't go over in the design tree and choose some plane. Just click the top of the part that you made. Okay. Start Hole Wizard. Everybody got Hole Wizard started with the top of the thing selected? Okay. So the 9 boxes here, we want the first one on the second row, the straight tap, which should probably already be selected. Our standard is ANSI inch. It should also be selected. Bottoming tapped hole should also be selected because it's what we did last time. But we don't want 632 anymore under hole specifications. Right. So we click the down arrow and we scroll down to 1032 and click on it.
None of mine are selected.
All right, so watch. So you started Hole Wizard, yes?
Yes.
Okay. Click this icon right here, this first one on the second row of the 9 icons. Straight tap, got that. Okay, good. Then under standard, the down arrow next to that, select ANSI inch. It should be the one at the very top and already be selected. Okay. Underneath that, under type, click the down arrow. There are 3 options. You want the top one, bottoming tapped hole. Scroll a little more under hole specifications. If you click the down arrow next to that, there are a bunch of options here, but you want to choose the one that says number 10-32. Okay, good. Okay, then in the next thing, your end conditions. They might be through all right now, like this appears up here if you look at the screen. Click the first down arrow here and choose blind. The second one should show up, and it should automatically say blind 2 times diameter.
Yes.
Okay, now, you see these boxes that look like chain links that are linked together? You notice mine are kind of dark gray. You want yours to be dark gray. If they look like this, the light gray, that's not right. You want to click both of them until they're both dark. Okay, now that those are both dark, what that's going to do is allow you to just type in your desired thread depth in the bottom box, and it will automatically calculate the engineering standard for the top one. So just click and drag over that so you select it and type in 0.5. When you hit enter, it will automatically calculate that the drill depth needs to be 0.5936. Okay, scroll a little bit more, and you have these options down here. Sometimes near side countersink is selected and it brings up some other options. I don't want near side countersink, so turn that off. The only thing that should be selected down here, oops, let me slide that back over. The only thing that needs to be selected down here is with thread callout. All right, now all you've done so far, Walker, is you set up the kind of hole. You haven't told it how many holes or where to do that. The way you do that is by you clicking the positions tab at the top there. Everybody with me now?
Yes.
Okay, so here's something to keep in mind. What always happens when you click the positions tab on hole width? It activates the point tool in a mode where it won't just merely put a point, it'll actually put a hole of that specification. So be careful now, you only want to click one time here on that top surface. If you're really careful, you might even be able to click it so that it drops it right on the origin first attempt. But if you don't, if you accidentally click somewhere else, it's no big deal. You just hit escape to exit the point tool. You go normal to it, and then you can literally click and drag that point to the center, and when you release, it puts the hole right on the origin. Does everybody have a hole on the origin? Okay, cool. So we're done with the point tool, so I'll close that dialog over in my dialog box. And I'm done with the hole wizard. So I click OK again in my dialog box. And now it gives us a preview of our 1032 hole in the end of that part. Yay! Now what we want to do is we want to apply that chamfer. Chamfer is just a unique variety of fillet is all it is. So if you go to your features tab up top and you look at the down arrow under fillet, chamfer is the other alternative. Choose chamfer.
With nothing selected.
With nothing selected, yeah. Chamfer with nothing selected. Now we need to set up our chamfer parameters first. And our chamfer parameters, it already has 45 degrees. So all we have to do is change this dimension to be 0.0625. Or for those of you who love fractions, that's 1/16. If you wanted to type that in, it's the same thing.
Yeah, I can't get to the.
All right, once again, for those of you who missed me describing chamfer tool, because the friends around them are too helpful and distracted them when I was talking, you click the Features tab, down arrow, choose chamfer, and then change the chamfer parameters to 0.0625, same as 1/16 of an inch. Make sure full preview is selected, and now move your mouse over, click the edge of this cylindrical device up near the threaded end. If you click the face by accident, it's going to apply this chamfer to the inside and the outside. You don't want that. So if you accidentally did that, just right click over here in the items to chamfer and delete, and try again to click just the edge. So it only applies the chamfer to that one edge, not to all the edges associated with the face. Does that make sense? Okay, click check. Groovy, done, perfect, great, awesome. Now the next thing we want to do is we want to make that groove. And if you recall, the corners of that groove were coincident with the chamfer. So what we need to do is create a sketch on this end face here. So move your mouse over until you're on this end face, not this angled face, but this end face of the part. Right click there and launch a sketch by choosing the sketch icon there, like we've done 1,000 times already. And then click normal to. So now we're looking just at the end of this part. We have a sketch launched. We're making a sketch and we're looking just in this part. Is everybody with me?
Yeah.
No?
I got behind the box.
What can I do to help you catch up? Where are you now? Are you doing the chamfer?
No,
Threaded hole?
when I was making the hole, you made two, so I tried to redo it. And then
It's not on the origin.
yeah, it's not like I'm changing my
Quite as silly.
So your initial sketch was not on the origin?
yeah, no, I made
Or the hole's just in the wrong place?
so I deleted it and redid it. Now it's not letting me put it on the origin.
Okay, are you trying to move it after you exited the hole wizard?
Yeah, but I didn't.
You need to be in the positions tab of the hole wizard to move it.
Yeah.
Did you turn off your point tool so you're not making more holes? You should be able to click it and drag it unless it has a green box associated with it already. Does it have a green box associated with it already? Click and drag the blue dot to the center.
There you go.
Click and drag the blue dot to the center. Okay, accept that change.
Yeah.
All right, we'll get you. You have to do the chamfer next. You can't do the next part without doing the chamfer. Help them do the chamfer and let me know when you're there. So exit your hole wizard once you get your hole in place.
Point 0.625, right? Or 0.0625.
0.0625 is bigger than the diameter of the part. That's it. You're done. Click check and you're done.
Oh yeah. Wait.
Is this fillet wrong?
I got inverted.
His went in instead of out.
I don't even know what that means.
Like instead of like, I think you click.
No, I think you got the
Oh,
top.
you
We
got the bottom.
added material instead of removed material? Like he added a ridge around
So
it?
instead of giving the edge of the actual circle, we click the edge of the inside circle.
Yeah.
So then it like.
Right, so that's pretty easy. You just, did he exit the feature yet? Or is he still in the feature dialog box?
Yeah, now it's.
So all you have to do is you go in items to fillet or items to chamfer, you delete the entry you had and then click on the correct entry. All right, so now, wait, he's not there yet, Lampert. You need to right click on the top of this cylinder, right click on the top of this thing and launch a sketch. Like, click the icon that creates a sketch.
Why is it so silly? Okay.
All right, and then click the normal 2 buttons so you can see the sketch like this.
The inside of it is so expensive. Oh my god.
If your chamfer's wrong, you can't go forward. Let me come to you.
Yes, bro. Was right. I don't know what you did now.
I think what he did was he made his angle 0.0625 rather than his, yeah, you got all kinds of problems here. All right, so, but wait, pay attention. You can right click on this and edit this feature. Okay, you don't want the face. You want to delete that. You do not want to chamfer the face. 0.0625, 45 degrees, full preview. You only want to chamfer just this. Your mouse is terrible. That's part. It's just that edge.
I've been lagging.
Once you get that edge, that's all you need. So there's the chamfer you want. Now you want to right click on this surface and start a sketch. Yeah, part of the problem is your mouse is terrible.
Yeah.
And then you want to go normal. There you go. All right. I want you to try this. What would happen if you moused on this paper? Does it work better? Yes, it works about 1,000 times better now. Get a piece of paper and mouse on the paper. Okay. Do I really have to yell at you again? All right, good. So you want to do a corner rectangle. One corner is on this transition at the edge of the chamfer. The next corner you just need to drop sort of in a random spot. Don't drop on an edge or on another edge. Just drop it kind of in there like that. And then hit escape to turn off your corner rectangle tool. We good with that? All right, now this other corner of this top edge here, if you click it and you notice you can move it around, Move it until it touches that edge, the same kind of edge that the other corner was doing. And you should get that yellow preview. And when you release, now both of those corners are coincident with that circle. See that? Other way you could have done it instead of dragging it to get it is you could click the corner, hold shift, click the perimeter of the circle, and add the coincident relation. Either one works. So you can add relations by dragging, or you can add relations by click, shift, click, add. Okay, just Control Z until it goes away. Control Z until it goes away. We got one rectangle, yes?
Yeah,
And one corner is, this corner is on this circle and that corner is on this circle?
yeah.
Good. No, I don't care what, you got that, you're good. Everybody with me? All right, we're gonna deselect that point by closing the dialog here. And then what we want is we want this line to be tangent with the outer surface. So click and drag it down until it's out a little bit like that. Choose it by left clicking, hold shift and left click on the outer perimeter of this part. And now you can add the tangent relation. By the way, this is very hard to do if you are not looking at it perpendicular. Part of the reason I insisted you get the perpendicular tool is that it won't let you select that outer perimeter very easily unless you are looking at it perpendicular. Perpendicular, then you can select it no problem. So at this point, you should have a rectangle. It should have the top left corner coincident with the end of that chamfer, the depth of that chamfer. The top right corner coincident with the depth of that chamfer. So that's what that little green box at the top right of your rectangle and the little green box at the top left of your rectangle are all about. They're saying those points lie on that circle. Then the bottom line of your rectangle should have this tangent relation box, a little box with the circle and the line in it. And that's making that line stay tangent to the perimeter of this part. You need something?
I mean, I don't know why. I don't know if this means anything, but it says sketch 9. Like,
That doesn't mean anything. Mine says sketch 4. You're good.
I'm missing.
Yeah, you just don't have that tangent relation yet. Okay, so click that line, hold down shift, click the perimeter of the circle. Good. Add the tangent relation. Click check. And so you're good. Although something's still wrong here. And what's wrong is the center of this circle is currently coincident with this. Personally, I would not have done a center point rectangle. I would have done a corner rectangle. You don't need that center point at all. Yeah.
I'm missing.
Because you haven't added it yet.
Okay. Wait.
So click over here so nothing's selected. Click that line. Hold down shift and click the perimeter of the circle. Add the tangent relation. Click check. So now you've got what I've got. You good? Okay, first off, I don't know what's going on over here. Let's do that. All right, so click on that line, left click on that line, hold down the shift button, click on the perimeter of the circle, add tangent. Okay, adding relations, guys, quiet please. Adding relations is something you absolutely have to learn. I just did it for 3 people. There's no reason that you should have trouble adding relations. All it takes, really, guys, I mean, look at it. I want this line to be tangent to that circle. So I click on this line. I make sure that's the only thing. It's just one line is selected. If you come up and you've got, the entire rectangle selected, it'll look something like this. That's the entire rectangle. I don't want the entire rectangle. So I'll click over here to deselect that and click on just the line, hold down shift, click just the perimeter. I've got one edge and one line selected. Tangent is the option. I add it and click check. Adding relations should not be challenging. Okay. Does anybody have a center rectangle selected? Max had made a center rectangle and actually ended up with an error. because the center rectangle was asking it to do stuff it couldn't do. We're all good? No center rectangles? Okay. All right, so the only thing left now is to do a dimension. So we're gonna go smart dimension. I want to dimension, I can dimension this bottom edge here like this, and it's 0.125. If you look at your drawing, you'll see that's 1/8 of an inch is the width of that groove. Click check, which is 1/8 as well, yes. Click check, you don't only need a smart dimension anymore, and in fact, you can exit the sketch. Okay, we're gonna finish this cut in the next 1 minute. While that sketch is selected, do extruded cut. Blind is fine, it's 1.5 inches. Is that correct? I don't have the drawing in front of me.
Yes.
1.5 inches. Click check.
Yeah.
Click check again. Scroll click and look, you've got the groove cut. It's not round at the bottom, but you got the groove cut. At this point, you want to save. Make sure you're saving in the proper place.
What should we call it?
We're going to call it axle. A-X-L-E. L-E is axle. E-L is somebody's name. A-X-L-E is a machine part. E-L is a name.
Wait, it's AXLE, yeah?
A-X-L-E.
What's
Or
the,
sometimes
Save.
That's like,
what's the vertical?
Close this. AXL is another way of spelling the name, but LE is the word.
What's the vertical smart dimension?
1.5. It's not a smart dimension. It's an extruded cut. It's a blind 1.5 inches. Save it and close it. Oh, that's all I have for today for this. I can.
Oh my God.